Hello, in this video we're going to look at an activity series, or at least part of one, and this falls under the Nevada State Science Content Standard, where students know that in chemical reactions elements combine in predictable ratios and the numbers of atoms of each element do not change. The objective is, upon completion of instruction, the students will be able to use an activity series to predict whether a given reaction will occur and what the products will be. So what is an activity series? It's a list of elements organized according to the ease with which the elements undergo certain chemical reactions. Or in other words, it'll tell you whether or not you put two reactants together and you're going to get a reaction. In some cases you won't. One example is if you put nitric acid together with copper, the copper is going to be gone. Drop a penny in there, it's history. But if you accidentally drop your gold wedding ring in there, nothing will happen to it, no reaction. The order elements are listed usually is determined by single displacement reactions. Elements higher up will replace elements lower down. And there's more to that than we will discuss in this video. Activity series will also show what elements will react with and under what circumstances elements may or may not react. Okay, so here we have some reactants. Now, simply putting them together is no guarantee that they're going to react. I'm sure that you've seen videos on YouTube of someone putting together some exciting things like water and milk, and there was a massive explosion. And then you thought, well, that's really cool. I want to try that myself. So you did, and nothing happened. The makers of those videos are probably laughing knowing that people are out doing such things. So understanding an activity series can help you in situations like that. Just because somebody says that something's true doesn't necessarily mean it is. So let's look at an activity series chart before we look at these reactions. Here we have an activity series chart, not a complete one, but good enough for our purposes. And over on the left we have activity of certain metals, and here you have different elements listed. And on the right you'll see a few of them as well. These are halogen nonmetals. Now these are grouped together in sections. You'll see a line across here. Any one of these elements, lithium, rubidium, calcium, barium, and so on, all the way down to sodium, any of these guys here, if they are combined with cold water, you're going to get a reaction, or with acids, and in either case they will replace the hydrogen. They'll also react with oxygen, forming oxides. In other words, they'll bond to the oxygen. The same thing would happen over here. If we took chlorine and combined it with cold water, what would happen is the chlorine would replace the hydrogen, and you'd have chlorine bonded to oxygen, and then you'd have hydrogen gas. And as we go further down, the next group here, we have magnesium, aluminum, manganese, clear down to cadmium. Each of these will react with steam, but not cold water, and acids. Again, they will replace the hydrogen, and they'll also react with oxygen, forming oxides. So for example, if you had magnesium and oxygen for reactants, you would end up with, since it reacts with oxygen, you'd end up with magnesium oxide. Okay, here we have cobalt, nickel, tin, and lead. They do not react with water, but they will react with acids, replacing the hydrogen. They will react with oxygen, forming oxides. And if we go further down still, we have hydrogen clear down to mercury. Each of these would react with oxygen, forming an oxide. I'm sure you've seen copper that looks kind of greenish or bluish on the outside. That's cupric oxide, or aka rusting penny, perhaps. You've seen green pennies. It's not really rust, but okay. And these last three, we have silver, platinum, and gold. They're fairly unreactive metals, which is partially why they're so valuable, and they'll form oxides only indirectly. Okay, so let's go back and look at some of those equations we had earlier. Okay, so we have nickel, and we're going to try and combine it with water. Liquid, H2O liquid form. So let's look at our chart. We'll look for nickel. We're just going down here, scrolling down until we, here's nickel. So we look at this group. Do not react with water. Well, we don't need to read any further there, do we? So here we're going to have no reaction. Whoops, no reaction. I can write this. Okay, moving on to our next one, we have tin and oxygen. If we put those together, let's see if we have a reaction. So we look in our activity series here. Here we find tin. Do not react with water. React with acid, replacing hydrogen. So far, we don't really care. Reacts with oxygen, forming an oxide. Okay, let's look back at our equation. This reacts with oxygen, forming an oxide. Now, we don't know what the charge on this is. It doesn't really say. Let's just assume that it has the same charge as oxygen. So that makes it a little bit easier. So we can put together one tin with one oxygen. Okay, we have an equation, but here it says to write a balanced equation, so we need to balance this. We have two oxygens on this side, so we need two over here, so let's just put a 2 in front of this molecule. So now we have two tins, we'll need 2 over here, so we just put a 2 in front of this tin. We have a balanced equation. Okay, simple enough. Okay, moving on to the next equation. We have cadmium, solid, and we have lead nitrate, aqueous. So let's see what happens when we combine cadmium with lead nitrate. Looking at our chart, cadmium. Oh, here it is right here. So we're going to read through this and see if it's going to react with lead nitrate. Reacts with steam, but not cold water, and acids. Lead nitrate is not an acid, replacing hydrogen. Reacts with oxygen, forming oxides. Well, there's nothing there that says it's going to react with lead nitrate. So that means we get no reaction. Okay, on to the next one. Okay, we have copper and hydrochloric acid. Let's see what happens when we put those together. Okay, we look at our chart. There's copper. Let's scroll down a little so we can see it better. We have copper reacts with oxygen, forming oxides. Doesn't say anything about reacting with hydrochloric acid. As I said before, this is a partial chart. There are some acids that will react with copper, but in general, it's not going to react according to this. So we're going to fill in no reaction. And by this time, I think you're probably starting to see that this activity series chart isn't really all that difficult, is it? Okay, let's try just a couple more before we call it quits. Okay, again, determine if a reaction will occur. If it does, you need to write a balanced equation. Move that over just a little. Okay, so we got lead, this time combining with H2SO4, which is sulfuric acid. So let's go to our activity chart, look for lead, and see what it, oh, there's lead right there. Lead. Do not react with water, reacts with acids. Okay, we're talking about sulfuric acid, so the lead is going to replace the hydrogen. So let's go back and make that happen. So this lead is going to be put where this hydrogen is. Okay, so what we're going to end up with is Pb for our lead. It's going to replace the hydrogen. So we've got SO4, so lead sulfate, and it replaced the hydrogen, but we need to make sure this equation is balanced. If we have hydrogen here, we have to have it over here. So plus, hydrogen's now going to be by itself. H2 is one of the 7 elements that When it's by itself, it's 2. It's diatomic. Okay, and here we have a single displacement reaction of one single element in a compound. We get a different element out and a different compound. They've traded places. And we have one lead, 2 hydrogens on both sides, and a sulfate on both sides. It's a balanced equation. Okay, last one for this video. We have chromium and water, H2O, gas form, solid gas. So let's see what chromium does with water in the gas form. Chromium. Where do we have chromium? Here we are, chromium. Reacts with steam, but not cold water. Okay, so, and we do have water in its gas form, so that applies here. So apparently we're going to get a reaction. Reacts with steam, but not cold water, and acids, replacing hydrogen. So this is similar to what we just did with the lead. This chromium is going to replace the hydrogen. So let's write our balanced equation. So we're going to have chromium replacing the hydrogen. Again, we don't know what the charge is on the chromium. It doesn't really tell us. Let's just, to make this simple, let's just assume that it's chromium 2 and oxygen is a negative 2. So 1-to-1 ratio. Okay, plus, still got to write that hydrogen in. H2. And we have a balanced equation. Another single displacement reaction, one element in, different element out, compound in, different compound out, and this is how an activity series could be of benefit to you. Thanks for watching.